pH value of chlorides is especially important because they are used in certain veterinary medicines and in medicines for humans. Because of this, a person should know the pH level of the chloride they are putting in their body. Ammonium chloride is a great example of this because it is used in certain cold medicines, according to Encyclopedia Britannica. The National Pollution Inventory states that chlorides can have a negative effect on the environment and on a person's health. Our hypothesis states that we believe the chlorides with the higher pH will be those that are more reactive. Because of this, we chose chlorides such as copper 2 chloride for being the one with the highest pH because it was one of the more reactive chlorides we tested.
When Megan and myself decided to test the pH of chlorides, we had the task of choosing which chlorides would be efficient for our experiment. We chose to use 8 chlorides so we would have a lot of variety for best data variation. We chose the following 8 chlorides: aluminum chloride, ammonium chloride, calcium chloride, copper 2 chloride, iron 3 chloride, magnesium chloride, potassium chloride, and sodium chloride. We chose those 8 chlorides because they were most accessible and attainable in the lab and easiest, we felt, to use. After discussing between Megan, myself, and our chemistry teacher, we decided to do 5% solutions for each chloride. Also, a source, UMass Amherst, suggested that we test the pH of each chloride 5 separate times and take the average of the 5 separate times for the best data entry. Each chloride needed 50 milliliters of distilled water and 5% of each chloride, so we converted the 50 milliliters to liters, then to moles, then by multiplying by the molar mass of each chloride to get to the number of grams needed for each chloride to add the 50 milliliters of distilled water to accurately test the pHs of each chloride.
The chloride being tested here is copper 2 chloride.
As for the lab procedures, to conduct the lab, we had a vernier pH probe that was Bluetooth connected to a school laptop that had a vernier graphing program pulled up that recorded the data of pH for each chloride. We got this vernier program from the vernier website. The number of grams of each chloride, as previously stated in the mass section for each chloride. It was important that we got the exact number of grams in order to make an exact 5% solution. After this, we added the chloride to the 50 milliliters of water, took the pH probe out of the solution it was in, and rinsed that off with distilled water. Then, as I submerged the probe into the chloride, Megan pressed collect on the vernier program, and it recorded the data for us. After we were finished with the pH probe, we left it in the chloride for about 5 seconds. When we were finished with that, we rinsed it off with distilled water, then placed it back into the solution that it came in, so for best data.
This graph shows the pH levels for each chloride with standard deviation bars showing how the chlorides vary between tests. Though each chloride varied throughout the test, there were some more consistent than others. Chlorides with large variation between tests are shown to have a higher pH. Whether that is due to the substance itself or the fact that the pH probe collected incorrect data is unknown. Variations are due in part to errors such as being unable to measure the exact number of grams we needed, or the pH probe hitting the bottom of the glass instead of collecting the data from the solution, or the pH probe moving, the last two resulting in measurement of the pH of the glass of the beaker we were mixing the solution in. Our hypothesis was disproven as magnesium chloride had the highest pH.